Hello, Miami alumni and friends. So glad to have you here for another webinar. I am JJ Sliger from the Alumni Association, and I'm eager to be here to give you Miami Presents AI Context Engineering. And I will introduce John Femiani shortly. I just want to say ahead of time, again, thank you all for watching. We have an awesome group of viewers for this AI talk. Again, we have parents of students, we have faculty and staff, we have friends of Miami, and we also have alumni from the classes of 1958 all the way to 2024. So we appreciate the crowd joining us to learn more about AI context engineering. We have a good amount of questions that were submitted ahead of time. John's going to cover a lot of the content that was in there, and we'll get to some of those at the end as well. But as a reminder, live questions are also welcome. We're going to make this a Q&A at the end, and we're eager to hear from you with your questions. So with all that being said, one other housekeeping note. This is part of our partnership with Miami Online. Miami Online is doing professional education, including an AI micro-credential learning series where you can earn an AI badge. And the professors that we've had teaching these webinars have done a separate similar session that's recorded. That's a class session that you can join if you follow the link below your video there. Okay, I think that's it. Without further ado, I'm going to introduce you to Dr. John Femiani. He's joined us before, but it's been a little while, and glad to have him back. He's a professor of computer science and the CSE graduate coordinator at Miami University, and he is joining us in a busy time of the year for professors, and so we thank him for his time, and I will pass it off to you.
Okay. We zoomed out far enough to see my collection of coffee cups. Hi everyone. This module that was shared was based off of a talk that I did on. It was prompt engineering at the time, and within a week or two later, this term context engineering rose to popularity. So what the real difference there is, context engineering, you can kind of think as an attempt to rebrand or broaden the scope of what we talk about when we use a large language model. So I've got a slide deck here that we're going to walk through, and just as a little bit of warning, we're pretty likely to deviate from this slide deck as we go through, because there's some stuff that keeps changing that I want to be able to show you and talk about, and some stuff that I think is really interesting that I can show in this format through demonstration rather than with slides. So if I move on to this next slide here, this is who I am. I am no longer an Armstrong professor, but I was last year. I do research in artificial intelligence, but where I work, if you can have the analogy of cars, you can have a whole variety of expertise about cars. So you could be an expert driver, or you could be the expert at building the cars and putting the engines together. And that's where a lot of my work goes with respect to AI, and specifically in computer vision. Now, I was told that some of you might want to have a broader context of what we mean when we talk about AI. So I'm going to step over briefly into another presentation where I talk about that, just to set the context. If you've seen some of the other speakers, I think Dennis Cheatham did a broad talk about AI, but still he was talking about this modern resurgence of AI. And from my perspective in computer science, when we deal with AI, it is not just a bunch of tools that you use. It's not the business opportunities that everybody's excited about. It's a research area. So this terminology AI, this concept of getting machines to think for you, is older than the field of computer science. I mean, you could trace it back to Babbage and Ada Lovelace trying to kind of encode knowledge into programs and having machines that could calculate for you. And you could trace it back even further if you wanted to figure out whether you could take all creativity out of being able to prove things true or false. Alan Turing, we call him the father of computer science. He wanted to know whether machines could think. He had a paper in 1950 that introduced this Turing test that depending on who you talk to, we can finally pass it or not, which is it artificial intelligence? Or is it sufficiently intelligent if it could fool a person or not? And the term AI, just the actual term, when people use it, I think is traced back to John McCarthy. He created the Lisp programming language, which, if you study computer science, it's a very annoying programming language with a lot of parentheses. And originally, it was coined as an artificial intelligence programming language. However, nowadays, most people wouldn't call that artificial intelligence, because another quote that you can kind of attribute to John McCarthy, in addition to naming the artificial intelligence, the thing artificial intelligence, is pretty much once you can call it, or once you understand how it works, it doesn't seem intelligent anymore. So, but basically, his definition is how you can make a machine behave in ways that would be called intelligent if a human being were behaving that way. And so when we talk about artificial intelligence, that's broadly what it means. What we're looking at right now, we're in an era where there is a lot of excitement. And the history of artificial intelligence has gone through multiple bubbles that have, in some opinions, they've harmed the research side of the field significantly. What happens is the field demonstrates promise, everybody gets excited, you have a lot of business opportunities, a lot of hype, a lot of rebranding of things, and then eventually the more hype you create, the higher the expectations you create. No matter how good your tooling is, eventually it'll fail to live up to this ever elevating set of expectations you have for the tool. And then you have these winters, these so-called AI winters. So you had some in the 50s, you had some in the 80s or the 90s, you keep having these bubbles and winters. But broadly, artificial intelligence includes a wide range of things, including Google Maps, things like planning your route. Logic is a big side of artificial intelligence. And at Miami University, we have a whole summer abroad in Italy where you study knowledge representation and logic. But it's not about machine learning at all. Because remember, artificial intelligence is about things that normally you think an intelligent human would be able to do. And we can do things that are intelligent without learning. Machine learning is just one of the intelligent things that people do. Not machine learning. Learning, human learning, is just one of the things that these intelligent humans do. But broadly, machine learning has really been capturing attention for a long time. And under machine learning, there are a variety of techniques, many of which, you used to hear the term big data, and that would be very small, efficient machine learning algorithms that you could run at scale. And then around 2012 in the research community and in the popular domain around 2015, you probably heard about a bunch of people talk about deep learning. And this is the explosion of very large neural networks that run on GPUs. And then finally, we get to the area right now. The technology came from around 2017, but it really took off probably 2020. Is these large language models and diffusion models, both built on the back of something called a transformer. Both of them are, unlike many other models, they are either auto-regressive in the case of large language models, or even a diffusion model can be thought of as auto-regressive through time. What does that mean? They don't just make a decision, they continually try to build off of what they had previously done. Sort of the way that a person would do. You just don't in one shot do something, you go through a process to make something happen. So large language models are currently what is grabbing the hype, and to some extent diffusion models, especially for things like video in the most recent time, because they're just so capable. They're very capable right now. People always like to point out the limitations, but that's good to do. In the research domain, we love limitations because they're things that we fix. And from the point of view of a user, today's limitations are tomorrow's features that work, that set you apart. So if we go back to that slide real quick, Where we live in the computer science department at Miami University is we develop the algorithms, the reasoning, the planning, the math, how to carry out the computation. It's also important when people talk about AI and when you come to micro-credentials and things like that, you might not exactly be interested in the science, the computer science side, but you might come to it with another approach. So for instance, I think the previous talker in here was very focused on the application or the tool side, right? So once you've got the science down, you can really use that to help build tools, and tools are what end up most conveniently in the hands of your end users. That gives you the broad mass appeal that gets people feeling engaged and able to participate. So that was what was great about ChatGPT, is they created a research preview that was so usable that everybody took off. That kind of made these large language models take off as a tool that people liked. They didn't really intend for it to be as phenomenally popular as it was, although I'm sure that they were happy it was. So tools would be things like chat, the chat that most of us probably interact with, but also coding agents. So in my particular discipline, a lot of people are using things like Copilot, Cursor, Claude Code, ChatGPT Codex. These are all specific tools that you would use for software development to help you not only write software, but also to help you ideate and explore ideas and prototype and even write up your research results. So, but then also a lot of people come to it interested in policy, because as people shift towards using these AI tools, it has large impacts in privacy, security, things like copyright, the jobs that would potentially be displaced. Although I think that this is a real problem, but there's so much opacity into exactly what's going to happen, and there's so much uncertainty that I see some questionable decisions made about that. So policy becomes a real important thing, but that's outside of computer science's area of expertise. So I've got this slide up just to address that comment that I was kind of asked to bring up. I hope that made sense. It was only mildly opinionated, but that's kind of the big picture of where AI lives. But where I think we're interested right now is pretty firmly, I expect, in the domain of where prompts matter a lot, which is large language models and other generative models. So large language models are a class of autoregressive models right now, although there are a number of diffusion-based language models. And if you don't know what that means, you can think of it as I don't know, a diesel car versus a gas-powered car, right? So there are different under-the-hood techniques being used for these. When we're prompting, let's focus on the classical case. You're going to describe what you want, and you want to get an answer from a large language model, an image from an image generator, a song from a sound diffusion, usually a diffusion model for sound, although some are autoregressive, or a video. What is prompt engineering then? So this is really a fancy way of saying that you need to understand how to be precise about what you actually want when you're talking to one of these models. You can really think of it like it says here on the slide, is giving clear instructions to AI. The immediate thing that you might think about is, well, I mean, isn't this kind of fishy? Because the next time somebody comes up with a new version of a large language model, OpenAI rolls out something new, is all of this knowledge that I learned about the idiosyncrasies of how to talk to Claude version 3.7 going to be out the window? And it turns out that there is a lot of robustness to this, and understanding how to communicate effectively to get what you want from these large language models overlaps probably 99%. All statistics are made up. 80% of them are, at least, with how you would do the same thing with any other intelligent agent, including your subordinates, your coworkers, your students, your children. And so it's really a bit about how to give clear instructions to get what you want, and adapt its behavior to your needs. Now, one of the reasons this matters a lot with large language models is large language models don't learn. Traditionally, with AI and machine learning, if you wanted to customize it to do a specific task, or you wanted to build a new tool or make it solve your own specialized problem, you would either train a neural network from scratch with tons of data, or you would fine tune it with a small amount of data for your own task. But large language models instead can be tuned or customized just by using their context. So instead of coming to the large language model and saying, when was Miami University founded? You can instead say, here is the web results of a Google search on Miami University. And then you throw tons of content you don't want to read. And then you can say, based off of that, when was Miami University founded? And in essence, by stuffing that stuff into the context, that's similar to training the model to be an expert on Miami University. So that previous stuff that it's read. So this is kind of those sort of ideas about what we mean when we talk about context engineering or prompt engineering. If we go to the next slide here. So this kind of leads to how you really want to think about prompting and effective prompting. So to begin with, we have our one-off AI interactions. So you open up one of these chat engines, and it doesn't really matter. Each one of them has different strengths that has a lot to do with the proprietary way that they're built and the way that they're trained by Anthropic or OpenAI or Google or Meta, right? So, but when you interact with them for their end user customer client interface, there's a lot of machinery that happens in between the actual large language model and you to help customize the response that you get. These include things like safeguarding it to make sure that you don't expose people to harmful information, trying to remove training biases by putting in the prompt, don't be biased, right? So there's a bunch of stuff that goes in there that you don't even see as a user. But then you open up ChatGPT and you really quickly say, how old is Miami University? And you don't know what happens, and it gives you a response. But those are your one-off AI interactions. And for those, you probably don't need to put too much effort into clarity. Although when you get back a result you don't want, you can go back and iterate and refine by adding more clarity and more specificity to get what you want. But it's not worth putting too much effort into making this well-crafted prompt if you're just going to maybe ask it once or twice. Where prompt engineering really comes into play is when you want to have reusable prompts and templates. So this could be that you want to make your own tool or your own app that other people are going to use. And on the back end, you're just going to basically be reselling Claude or OpenAI. But basically, you want this one to be a specialist on how to schedule your workouts at the gym, or how to cook recipes. And so in this case, you want to make a prompt that's always going to format its output the correct way that you need things to be formatted to integrate into the next part of your tool chain. That's always going to give them the answer. Maybe if you're doing recipes, it should always be a recipe, and you should always make sure that you ask them what ingredients they have or what dietary restrictions that they have. And you can put all of that kind of pre-scripted behavior into a prompt, and you can also stuff it with a huge database of existing recipes and nutritional information and foods that go together and don't go together well, for example. So that is kind of this second case where you might want to have these reusable prompts and templates. And then finally, when you're really putting it into developer mode. And there are areas of research right now and tools that are available. I mean, some that I probably had running in the background where here we go. We've got OpenAI agent mode doing something for me in the background where it's trying to solve a problem. Let me see over here. Oh, in the display, here we go. So there's OpenAI in agent mode trying to fix a bunch of URLs in my PowerPoint slides that aren't right. So that kind of agent mode behavior is, oh dear, I lost the StreamYard link. There we go. That kind of agent mode behavior is where you begin to say, now I have, instead of having one huge prompt, I want to have multiple asynchronous, imagine that they're different people, and then each one has a different set of tools that they can use. So one can click on buttons, one can go browse the web, and each one in my prompt, I've explained how to use those tools effectively so that everybody doesn't need to know everything. So each LLM can be focused on one area of expertise, and you can coordinate them to get a big task done. So that's sort of these multi-agent systems. And I don't think anybody here is building multi-agent systems, but you might be using them. So if you're using Claude Code, or if you pay for OpenAI, if you pay for it, and then you use that little agent feature, or if you're using Copilot even, and then you click on agent mode in Copilot if you happen to be somebody who does any kind of code editing, then behind the scenes, you didn't develop all of those prompts, but somebody else has kind of created a whole coordinated system of agents, each with their own prompt in order to do something. And in this case, in order to make them reusable, you have templates with variables that you can substitute things in, and you want to evaluate and test them to make sure that you get reliable results from them. So if we go ahead here. So at this point in time, maybe I'll suggest, because I'm going to go do a demo probably after this slide, in a slide or two. If you guys can think of something that would be a good thing that you might want to have as a reusable prompt, like you can imagine a tool whose interface is just interacting with ChatGPT. And so you can describe, I think JJ said, a vacation planner. Just think of something, because I'm going to go back and I'm going to try to demo something. And it would be good if we had like a task so we can, I know it's risky to do things live, but we can try to do something live and see what happens when we try to play with one of the playgrounds, the OpenAI playground. But for now, just think about it. And if you've got something that's burning in the back of your mind, maybe JJ can give you a way to ask him. But and I'm giving a minute for him to do that while I kind of talk this. So here is just sort of prompting in practice. If you're doing a one-off prompt and you're a student, let's say you're in a computer science class or a math class, and you're getting confused, and so you say explain recursion. Now, this is traditionally called a bad prompt. A good prompt here with that little check mark would be, you're a computer science tutor, explain recursion to a beginner using a real-world analogy, blah, blah, blah. I'm not going to read the whole thing. So again, many people would say that first prompt is bad, but in reality, if it gets you the answer that you want, it's a great prompt, right? And think about all the keystrokes it saved you just by being able to type 2 words. Or even better yet, maybe you clicked on a little microphone and spoke into ChatGPT. Really, a good prompt is one that works. The reason that people would argue that the second prompt is better is when you need consistency across multiple uses, detail becomes valuable. And for repeated use, we want a structured approach to prompting. So again, a one-off works when you want consistency, but when you want efficiency, you need a template. So this original talk was aimed at prompt engineering for educational purposes. And it has a link. When you click on that link to more useful things, this person put together a library of prompts that are useful for education. So these are kind of convenient because this is where I can go to give you an example of some prompts aimed at instructors. And because ChatGPT came out with ChatGPT 5 very recently, this hasn't been updated. And the question is, does it even need to be updated? And in principle, it might not be. But here we can see that you might want to have a prompt that you can share with your class about project ideas for a class. And if we look at this, we can see that it's quite detailed, and we can kind of break it apart and look at some of the features that it's got. So number one is it assigns a persona to the LLM. So the idea, this is there from the very beginning. It partially has to do with the way that it's trained, which is that large language models will typically pay a lot of attention to the very first thing that you say to them. And then their attention drifts off, and then they pay more attention also to the last thing that you say to them. So that very first thing that you say to them can set the tone and the structure and the voice of the rest of the conversation. So you'll always see that there's a pattern in these prompts where at the very beginning, you're going to assign a role to the prompt. You are a practical teaching assistant and an expert at coming up with ideas for class projects. If I'm a bird watcher, I might say you are an expert at birds, and or if I'm interested in recipes, I would say you're Julia Child, right? If you give it a specific person, it will that has a lot of content on the internet. It will figure out the way that they communicate, their verbal patterns, their dialect, all of those patterns of speech, and bring it over. But if you pick a broader category, it will just couch the way that it responds. It'll speak either as an expert, or you could say you're a 12-year-old, and it'll speak with a different language. So we tend to start with those. Here we can see this is a prompt. You're a teacher. Too many questions can be overwhelming, 2 at a time. So it doesn't just use one word. This is a result of the person who wrote this, trying this prompt many, many times, looking where it got wrong, and then trying to refine it. It has examples, wait for the teacher to respond, then ask this. So it describes a whole process to go through. And importantly, in the prompt, it has these set off things, which are kind of template things that you could fill in, right? So very often in a prompt, you might want to indicate where your variables or your templates are that you want to replace with other things. So if we look at some of these, we could see that there's a number of big prompts that this person shares with us. So you can select one of those big prompts, and you can pop over to an instance of ChatGPT. And here's an important point that I should make. Number one is recently ChatGPT came out with GPT-5. I am temporarily going to go back to GPT 4.0 to demonstrate this, and then I'll talk about some of the breaking things that happened when they released GPT-5. But here you kind of paste that prompt in, and you can see that because you've done that, in essence, it's almost like you programmed the large language model. It's going to go through the process, and if you were clear and precise, so you can think about it just like if you're a programmer. A lot of people, I'm sorry, I didn't realize you couldn't see my screen. I pasted that chat into ChatGPT. I selected GPT 4.0 up here, legacy models GPT 4.0. I pasted an entire prompt into here, and then it began to follow the instructions. So it's following this set of instructions rigorously. And the point I would make is that this is very similar to the way that you would interact with, you would do coding, you'd write source code, except, when you're writing programs, you know that you have to be super specific. And the reason that programming languages are like this is, number one, they need to be unambiguous for a compiler to interpret them. Now, in principle, a large language model can deal with a lot more ambiguity, and it can resolve what is meant even when you're less clear. But it's not perfect. There's randomness. So here's the important thing about context engineering and prompt engineering is it's engineering still. And you're trying to choose your prompt, and you're editing the way that you say things, even though it's not at the same level of rigor of compilable programming code. You find that you will have to get extremely specific, as if you're talking to somebody who will do everything that they can creatively think of to get your instructions wrong. So again, hello, I'm your diagnostic assistant. I can give it a topic, and I can give it a learning level. So I want to talk about prompt engineering for 12th graders. I know that you're not 12th graders, but I think I always prefer to be taught at a level that is somewhere below where I think I am. So, and then it'll just follow through the sequence. I'm not going to go through this whole thing, but this kind of prompt is kind of a cool example of a prompt, and the link to all of those prompts is in my slides. I'll try to share that with JJ afterwards. Just as a quick note, all of my links kind of went bad, but This one was, can we zoom in through this tool? It's moreusefulthings.com. There we go. / instructor prompts. So there we go. Boom. I don't know what else is there in More Useful Things. They have a prompt library and some other stuff that you might want to look at. AI coach, etc. So they have meta prompts to help you make prompts. So this is something that I would recommend. If you want to know more, you can look at that. As well as you can find, if you look online, a variety of prompt libraries. But I have to warn you that many of these prompt libraries, they're just funny little toys. Act like a motivational speaker, act like a rapper. Some of them are useful, but many of them are people playing around. And that's fine. But it may or may not be a serious thing that you would want to do. Whereas that educational one, thank you for typing that in, is along the lines of a more serious application of prompts. So some key points to take away from that is that the prompt is excessively detailed and that it's been iteratively refined. And if you look at some of the things that are in there, so sometimes the prompt in More Useful Things would say something like, let me just look at, I think this is where I was, active learning co-creator. I remember one of them said, don't reference learning styles. Learning styles are a myth, right? And the reason that it said that is because, actually I can show you. Okay, I copied the whole prompt in here once. Reminders, do not explain what you do. Don't mention learning styles. This is an educational myth. So these are all things that they added to the end of their prompt. I kind of formatted and highlighted one of the prompts so you could see the structure a little bit better. The large language models, I mean, they just get markdown text, so they don't necessarily see the bold. This is for us. So it'll ask you for the role, it'll ask you for your goal, but at the end, it has some of these reminders. And what it's doing here is it knows because when they tried it out and then they tested it. So they tried it on a bunch of projects, a bunch of roles, a bunch of different goals. They tested it out 10 times or however many times that they tested it out. And they found different ways that it messed up. And because they want them that's reusable, that they can put out at scale, this is part of the engineering process as you kind of create your testing and evaluation benchmark to see where it goes wrong. And when they are finding out that it goes wrong, they're going back and updating and modifying the prompt to make sure that it doesn't make some of the mistakes that they care about. So what you can actually do is, you know, how it asked me for what the topic is. And if you want to have this work for different topics and you're developing a prompt, there are tools that will help you with this, but you can also just pop up a spreadsheet, which is a lower level of technical difficulty to make it happen. But you can just pop up a blank sheet like this, and you could just do something like, this is the topic. This was the entire prompt, and you could paste it in there, and then you could say whether you had any issues, right? And you can kind of track them over multiple different topics that you test, and you can go back and update and refine the prompt while you're keeping track of it in a Google Sheet. That's always going to be a good idea. So again, this is where prompt engineering is engineering. So another point that I wanted to bring up, let me, I've lost the StreamYard again. Here we go. Another point to bring up is that when we talk about context engineering, there are ideas out there. So some people might say, again, context engineering isn't needed as these models get better and better for a couple of reasons. And while in some sense you can understand that perspective, the only reason that that's potentially true is, is that you're not seeing it. The context engineering is happening behind the scenes. what is also happening is that context in these models are getting longer and longer. So you've got these Google things with a million or 2 million long prompts. You've got research on, having infinitely long prompts out there. But what's happening is that even though the prompts, the ability of these transformers to deal with longer and larger prompts are growing, they aren't actually solving the problem. So let me kind of explain just a little bit under the hood what happens as your context gets longer. So when you're chatting with a large language model, I might have a graphic to show this. Here we go. So let's say you're chatting with a large language model. You have a bunch of words. So in this case, you might have the word don't rob the bank today. And so those words form your context, this entire stream of text. There's both what you say and what was said, what you didn't say, that was prepended, that you didn't see invisibly, that somebody else put there. All of those things form that context. And the way that these large language models work is they use something called a transformer. And the transformer takes every single word and it learns how to transform, embed those words as vectors, which I've kind of illustrating here. Each word just gets some more abstract embedding representation. And geometrically, these embeddings represent points on a sphere, right? So each possible word or token can be thought of as a point on the sphere. The direction of that point carries its meaning, and the length of that vector, it can be made longer, so it's not on a sphere anymore, if it's more important to the problem, right? So those word vectors are here, and those word vectors are fed into a transformer. And then that transformer, that transformer then goes back, and for every single word, it compares it with every single other word. So if I had 10 words, I would compare today to every single other word to figure out how important they are, right? This is called a dot product attention. And you mix together those concepts. With the example here being, if you look at the word bank, bank could mean a riverbank, so you see that up here, or it could mean banking your airplane, or it could mean the financial bank concept. But we don't know what it means as a word by itself. In order to figure out what that word means, the large language model will compare that word to all of the other words in the sentence. But in doing that, if you have n words compared to n other words, it's n squared different operations that it has to do. And then it ends up at the next level with a different representation of your context. This intermediate representation has now been enriched. It's still represented by a bunch of vectors, so it's transformed them from one space to another space. But in this space, each vector now doesn't represent a word anymore. It represents more of a concept, a higher level of abstraction. So now that bank vector is pointing directly towards the financial bank concept, presumably. And rob is not the name Rob, but the robbery concept. So it's able to resolve these concepts. And you stack these transformers deeper and deeper and deeper. The larger the space of this hypersphere, so it's not 3D, it's 512D or 4,000 dimensions, the more parameters this takes, and the deeper the network, the more parameters it takes. But what happens is, as you get deeper in these networks, these things tend to build an internal scratch pad of ideas, and we don't exactly know what those vectors mean as they get deeper, but we are able to inspect them a little bit and learn that those vectors have built an internal world model, so you can train it on chess moves, and then you can actually figure out that you can you can draw the chessboard based off of those internal vectors, right? So it's actually built a model of the chessboard as a toy example, just to prove these are building internal models. And they can also plan ahead and be deceptive. And all of this stuff is kind of baked into this context that moves through. But the problem here is that it's an order n squared operation. So when you start getting a really long context, it starts to use up all of the RAM in your graphics card, and it starts burning a lot of electricity, and it gets really slow. So you don't want to have a long context. And even more significantly, as the context gets longer and longer, we get this sort of context rot effect where it can't effectively use all of the tokens. So for example, there's this lost in the middle, how language models use long contexts. This is an older one. There's more recent papers digging into this more about how when you give it longer and longer context, it actually can't use it effectively. So it's going to be able to be accurate for things that are at the beginning, or if you have a short context, and it's going to be accurate for things that are near the end. And then, of course, if your context is short enough, the beginning and the end are the same. So the point here is that even when you have models that can have millions of things in the context, that doesn't mean that I can just dump the entire encyclopedia in and then ask it questions, and I don't have to worry about engineering anything. You still have to figure out how to effectively use your context. People try to train this by figuring out whether you can find the needle in the haystack of the context. They'll let facts through, and can you find a fact if it was buried in the middle? And it can't, but you can find it at the beginning. So there's that little bit that's useful to understand, that there's that context. The other thing that is kind of useful to understand when you're using these large language models, if I go back to this one again, is that when you interact with it, you don't see everything. So you, as a user, think that your interaction starts here, where you say, how many cups of sugar does it take to get to the moon? But before you've said anything, on your behalf, OpenAI or whatever tool has already set usually what's called a system prompt to the large language model that includes a lot of text. The large language model doesn't know the weather, it doesn't know the current date, it doesn't know that it's a large language model unless you tell it. So usually your system prompt will be a role, you're a helpful assistant, your OpenAI version 1. You might have a guardrail. If a question seems about a real person, don't identify them. Your knowledge cutoff is November 2024. So if that was when it was trained, it's not going to know anything after that. And then something like today's date is October 8th. I put this together yesterday. I put this together knowing I would be talking about it on October 8th, right? So this system message can actually be quite long and use up a fair amount of your context. So that system message is prepended to your user thing, and then the assistant comes back. When your actual context is a set of tokens that's said to the large language model, Tick Tokenizer is an app you can look at. I can go ahead and show it to you. So if you go here to Tick Tokenizer, you can type whatever you want to. You're a helpful assistant. How many cups of sugar does it take to get to the moon? And you can really see what your large language model gets is not just your message, how many cups of sugar does it take to get to the moon, but it gets the entire conversation, including a system message, and you can have multiple messages that typically alternate between user and assistant. So all of those tokens, all of those messages are tokenized, and extra dummy tokens to indicate that this is a message start or end, or this is a system message. For instance, it's a system message. Those are converted into numbers. Each one of those numbers is converted into a vector like this one and fed into your large language model, as I showed you. You don't see the system message when you talk, and you also don't see, for instance, if your large language model can use a tool, like if it can go out and browse the internet. So if it's going to be able to go out and browse the internet in that system message or somewhere similar, on your behalf, it lists which tools exist, which arguments that they take. So these would be function calls or REST API or model context protocol stuff. and a description of it so it knows when to use which tool. And then you ask a question like, what's the weather today? And then it decides I can do a function call, and it uses a special token for the tool call. All of this stuff is going into the context as you interact with it. There we go. So this is, let's see if we keep going here. Right. And then finally, you've probably heard of the term RAG, or retrieval augmented generation. And even that is getting put into this context. And remember, if it gets too long, it doesn't work very well. So what we're trying to do is be smart about how we use it. So if you want to ask, when was Miami University founded? Instead of stuffing everything that it might need to know about Miami University into the context, what RAG does is it feeds it through a transformer to get a concept vector that summarizes that whole sentence, right? So it'll push it all the way through, and then that last vector that it gets out of it would be one of these concepts about what we mean. And it runs through a database of facts that it maybe scraped from somewhere else. So this would be called a vector database. And you can take that concept and compare it to one of these vectors. And if it is similar to, in that concept space, university history, then it would retrieve that fact. And you can add, so this doesn't go into your context. This is being used to keep my context from getting too long. It'll put just that fact into my message. So I think I just typed in, when was Miami University founded? But what the large language model sees is the relevant fact followed by my question. So all of that's getting injected in there. So that's just a little bit of context. You think your interaction is short, you use the chat interface, but you don't see everything that happens. So that retrieval augmented generation thing that I talked about in ChatGPT, this includes what it calls memory, and it has all kinds of facts about yourself. So if you were to go into ChatGPT, if I come over here, boom, and I say, I don't know, what is my name? I'm going to switch from GPT-5, go to legacy model GPT-4o, and I say, what is my name? In theory, it shouldn't know that, but it does, right? So how does it know that? And that's just because secretly it's added information into the context that I didn't put there. So if I don't want that to happen, by the way, what you can do is you click on this little temporary chat here. And now I believe it doesn't have my, let's just confirm. This is a way to avoid some of that context rot. Okay, apparently I was wrong about that. But this problem is a part of it. So a temporary chat, it doesn't remember your chat afterwards, but apparently can still look at your memory. So the point here about why you might not want to, why this is an issue, is when you try to test your prompts or you try to test what you're doing from a context engineering point of view, everything that you do has kind of been corrupted by invisible things that were done in the background that you didn't see. And if you didn't know that, that could be quite a surprise. So if you want to avoid this, I was hoping that the temporary chat might be useful to you, but apparently not. Okay, that link isn't working. I'll just type it in. Instead, what you can do is you can go to the OpenAI Playground. So the OpenAI Playground is really, when you're doing context engineering, you're often doing it from a developer's perspective. So everybody in the audience might not be able to get directly to this screen, but if you type in OpenAI Playground, you might have to create an account, and then you might also have to put a little bit, set up a little bit of billing. The idea here is, normally with the free version of a language model, you have some limited capabilities, but if you pay a little bit, like $30 or $25 a month for ChatGPT, you get a lot more abilities, but you've subscribed to it. There's actually a kind of a trick. If you don't want to subscribe, but you just want to try it out, you can put $5 into this interface. So this is the API interface, and I'm not gonna navigate through the dashboard too much, but you can go into billing, and you can just pay $5. So you haven't subscribed to anything. You put $5 in, and once you put $5 in, you can proceed to use it just like ChatGPT. But instead of it subscribing, you're paying a fraction, like a thousandth of a penny, for each interaction, and it lasts longer than you might think. So here you can kind of play around with the interfaces. So if you hit chat, you can create a new chat interface. So this is used by developers to test out their prompting, and it gets rid of all of that hidden secret stuff, so you can figure out exactly what works. I don't want to use GPT-5 because it does all of this reasoning stuff, and I want to skip the reasoning. So I'm going to go to a smart non-reasoning model, GPT 4.1. And if I come here to chat and I say, what is my name? It should not know the answer to that. So this is kind of how you can get like a sterile environment to test out your prompts to see how they work. And here you can begin to also experiment. So that system message that you don't normally see, I can put it over here. I can say so here's where I'm going to go back to that question I asked you. So did we get any answers of tasks that we would like to set up an AI to do?
Yeah, we got a few choices, John. Tina was asking about collecting all NFL scores and whether the winners covered the spread. I'm not sure if she's trying to figure out some type of model for sports predictions. Jeff also agreed with me, asking about vacation planning, getting it to know his family for future planning. And then a third option for you, Rebecca said she wanted help with weekly meal planning, considering a calorie and protein goal and food preferences.
Okay. So let's do, it sounds like well, I'm going to do the protein goal, or the recipe one, because that's going to let me demonstrate function calls too. I guess the NFL one would as well, but I'm not as much of I don't know enough about the NFL. So we'll do the weekly meal planning, right? So here from the dashboard, the first thing that you could do is you could say, you are, I don't know, a meal planner, a nutritional coach. You will help with weekly meal planning. Weekly meal planning. I don't want to make you wait for me to type everything. I'm just gonna paste. There we go. So I also often like to use text to speech. So here we go. This is probably not a good system message, but I'm going to put it in here anyway. And then I will get rid of the conversation history. So this is my system message. And over here, I could practice. I could have a mock conversation, and I'll show you that in a second. But for now, let's just say, okay, basically, what should I eat this week, right? Right. So this is sort of a naive thing that a student might do, and it maybe will get results. Maybe they'll be okay. Maybe they won't be okay. It's coming back with a bunch of questions, which is a reasonable thing for it to do. Your weekly, I don't want to get into all of that, but let's say, I don't know, 2,500 calories per week. Let's say 150 grams of protein. I dislike carrots. I don't know. And how many meals and snacks do you want per day? 5 meals per day. Quick prep. And favor variety. I just want to see what it does here, right? So we can have this little interaction, and it does something, and maybe we like it, maybe we don't like it. But there we go. So stop. So this is a a vanilla interaction, and we can look at what happens. So if we come up over here, we can see this is a test interaction that we just did. If we look over here and we click those two dots and I look at code, we can kind of see what actually happens behind the scene. So it sends my system prompt, and then it sends the user's prompt, and then we get back all of this assistant, this stuff from the assistant. So it was a really long answer, and it started off with questions. And this is where sometimes iterating can help. Maybe you like that it started off with questions, or maybe you do not want it to start off with questions. Or maybe you'd like to start off by telling it something about yourself. Maybe you want to be able to have it have the ability to go and look up stuff on the internet. So all of those become things that you can do by editing the prompt. So the first thing here is this is a short prompt. I was actually pleased with how well that worked. But if you click on this little pencil with an arrow here, or equivalently, if you're not using this tool, but you're using ChatGPT just directly, you can literally ask ChatGPT to make a better prompt for you. So this is called meta prompting, because obviously the large language model, it's helpful in so many things. Why can't it just help you make better prompts? So here we can see just by feeding it through it, it improved a little bit more. It says you're a nutritional coach, assist in weekly protein goals, gather and consider all relevant details before suggesting a plan, ensure each day's output format, present the plan as a markdown table listing each day and calories, right? So add a summary line. So maybe this is what I want, but see how this is much more detailed, and it's explained the output format. So this is already a better prompt, right? You've got more details, you've got more examples. The other thing that you can do to make the prompt better is to give it an example. So you'll hear the term, so this is called setting a persona, where you tell it what it is. You'll hear this a lot. You'll also hear people just say details, details, details. So here it automatically provided more details. And if this was a real problem, I might give it even more details. Like we saw in the example prompt over here, where they set this thing up to help you create a project. They put a ton of details in. And then a critical aspect here is that, number one, it's using this thing that begins with a little hash sign. This is a markdown header. So this means it's a new section that's important. And then down here, we're talking about how we want to deliver the output. And this is often significant. And it can be significant just for convenience for you. You might want to actually have it produce output as a CSV file. With headers, day, meal, calories, protein, right? So this, if you say CSV, CSV is a format that you can open up in Microsoft Excel. So if you can get it to output in a CSV format, now through what you've done is you've given it something that's useful, either programmatically. So if you're going to use this prompt as part of a chain where something takes the result of this prompt and does something with it programmatically, it can do with the table, or just for your own convenience, something that you can download and then open up in Excel, right? Put the CSV in a block. Okay, so here you can also provide examples. Basically, what should I eat this week? You can imagine that the user has typed that, and then you can say what should the assistant output. Again, you should have day, meal, calories, protein on the first row, and then the next row you could say like Monday, chicken, I don't know, 230, right? And you could go on if you actually had an example. I don't have a real example. So actually what I'll do is I'll use the model itself to create an example. Don't ask me any questions. Just guess the answer. What should I eat this week? Right? Because I don't want to deal with those. And here you can see this is an example of comma separated values, except for the fact that if I was to take this example of comma separated values and paste it into Google Sheets, which I had up just a second ago. So let me bring it over here. So if you take comma separated values and you paste them into Google Sheets, it should be able to okay. If you were to save it as a comma separated, there we go. Nope, it didn't do that. Didn't understand it as well. If you save this as a CSV file, it would definitely have split it at the commas. But the problem here is, I don't know why it didn't split it, and I don't want to debug while we're recording this. But normally, there we go, split text to columns. The problem here, I thought I saw a problem. Yes, it put commas where they didn't belong, right? So it's got some like cucumber and tomato. It put like a chickpeas, comma, cucumber, comma, and tomatoes, and that messed up the formatting. So this is an example of when you're kind of testing it, you can see a problem. So basically, if the CSV text has a would have avoid commas in the CSV text. And this is called iterating, right? So you have to go back and iterate and refine your prompt and test it to see how it works. So here I can actually try it again. Oops, oh goodness. Or I can do something like this. And I can do the thing where I can say, what should I eat this week? And add a message, day, meals. So here it says comma, so it's got a comma there. So if you don't want it to use the comma in CSV, you could say, actually you can do this. Here is what not to do. Boom. The issue, there's a comma after the word salmon and after quinoa. This is invalid for CSV. Now, I'm not going to take too much time in here, but you can actually see that prompt engineering is indeed needed in order to get the thing to behave and produce output in a reasonable, goodness gracious, in a reasonable format that would be helpful to you. And if we were to test this again, what should I eat this week? No questions. What should I eat? And we run it. Hopefully it doesn't mess up the formula. Right, okay. Not ask me any questions. Just answer. What should I eat this week? Okay. So hopefully, so now it's messed up further. It's gotten rid of all of the commas. I'm not going to continue to tweak this, but this is kind of the point that I wanted to make. If I take this thing and I save it, if I switch to, let me switch to like GPT-5. What am I doing here? Oh, I see. Switch to the responses API. So what you can actually do is you can add variables to this. So something like today's date is, and you can put a variable in there. So let me put date as a variable. So this becomes something where it can plug in that date. And every time I interact with it, I can put what the current date is. So that way, if I was actually using this prompt as part of a tool, I can add context information that would be available when you actually use the app, like what is the current date. This is then when you can, once you've done that and you save this prompt, whatever, nutrition. Okay, go away. Then I can actually evaluate it, right? So you can set up a whole testing framework where I can put different values for each variable, and then what the output should look like, and I can go back and I can do this bulk test to see under what scenarios does it fail and under what scenarios does it succeed. So you can kind of run these things in batch with the tool. So again, this whole aspect here, the point here is that as an engineering thing, it's not just try to come up with a prompt that gets my current job done, but it's actually a whole rigorous benchmarking and evaluation process. I've got more slides, but how am I doing for time?
Well, we're at 107, so if you want to hit some questions soon, that's probably good. But if you want to share a couple more things, that's fine too.
So the other slides I have were links to some of those examples from the instructor thing where you can actually interact with the tutor, but the links don't really work anymore.
Yeah, well, let's get to a couple questions then, if you don't mind. Thank you for sharing all this.
Yeah.
Go.
Sure. The only other thing I have here is when we talk about the structure of a prompt, and I went into all of these other things because I think in my main talk I already hit this, which was when we talk about what the structure is. Define the task, what's the context, give it explicit instructions, tell it what the output format should be, give it constraints, so how many words, etc. And then, of course, this process of refining and adjusting. So you can see this slide, but I'll stop for questions now.
All right. We're going to let questions come in. One quick one that came in, John, was about formatting content. You showed an example of taking something out to a CSV file.
Yeah.
Are there other ways that you recommend exporting content? Does it work in Mac? How do you get stuff from your large language model into something that you're actually using?
So there's two sides to that. So the most common format that you're going to export to would be JSON. It's JavaScript object notation, and these models are really trained to understand that really well. Another common format you would output to is XML. So that's where everything, you know how HTML has those angle bracket tags? That would be another common format that you output to. When you're providing data into it, it's pretty common to use XML tags to delimit that. So we saw that, I don't have it here, but we saw that in one of the other slides that I had pulled up where I tried to put here we go. So this kind of thing is XML, where you just bracket information by those tags. Many programming tools know how to scan through for those tags and pull out the stuff that's inside of them to interpret what it means. So, but yeah, I mean, to some extent, just through prompting, trying to massage it to get the exact format that you want is a challenge. But that's useful. There are cases also when you're really trying to fold it into a pipeline with multiple things involved. I lost track of where the playground was. The other thing that you can do to get the format that you want is under here, if you hit tools and you hit add, you have the option to tell it to use a tool. So I'm going to switch again to GPT 4.1. And again, up here, I'm using the responses API. Claude will have something similar. Your older models, you might have to just say, respond using XML with the following schema. And then you would put something called XSL. It has a schema definition language. Just like with the CSV, I told it what headers to use. But in some of these tools, you can actually use the AI to help you with it. So recently, this summer, they came up with a standard protocol for tools. Now, you asked about output formats. The interesting thing is that some of these APIs will use tools for you, but very often what they'll do is instead of using a tool, these are the hosted tools, it'll come back to you telling you which tool you should use. And that's a way to kind of get it to output stuff the way that you want. So you can come over here and say that, let's say I hit generate, and you can describe the format that you want the output to be. So basically you could say, I want a recipe, or I want a meal plan where each meal has a name, ingredient list, calories, macros, and a day and time associated, right? And again, we'll let the AI come up with a reasonable schema for us. And here, so this is a JSON schema. So here, if you use this in your tools for OpenAI, they'll stuff all of this information. They'll tokenize it and put it in the context. You don't see it, but it's there for the LLM, so that it knows that a tool exists for generating the meal plan. So when it's going to generate the meal plan, it should do this. It needs to have a meals parameter, a list of meals, and it looks like I'm asking it to call a function, but in reality, I'm just going to give it a stupid prompt. Like, there we go. Nutrition coach. I'm telling you need to engineer these stuff, and then I'm typing a one-word thing. So we're going to generate a prompt for a nutrition coach. Well, okay, fine. Then I'll just say, ask me no questions. Just give me a meal plan. Guess the answers. Okay, so I just don't want to have to interact with it because that would slow things down. But what this will actually do is it will generate a function call, and its answer to me, instead of being text, its answer is actually formatted as JSON, right? So this is now giving me all of that information instead of as a CSV, as this JSON object that we see right here in front of it. These are the macros. And the beauty of that is all of that data is completely parsable using tools like Python. Did that all show up right in StreamYard?
Yep, I think so.
It was probably overwhelming and really fast. But yeah, from a coding point of view, getting it to output in the format that you want could be a trick. But things like that function call to get structured output as JSON is a really common way to do it.
Yeah, and then another quick one that I noticed that I didn't know before is you said a hashtag in a prompt. Most systems realize that as kind of like a new topic, or are there any other, can you expand on that? And there any other little tricks like that we should be using?
Sure. Yeah. First of all, that was Markdown. And if you're not too familiar with Markdown, Markdown This, by the way, I'm showing you Google Colab. People use it to practice coding, but it understands Markdown. This is a heading.
I think you need to move it over to the other screen.
Oh,
Sorry, Jim.
sorry. Yeah,
No problem.
Here we go.
There you go.
That's a heading, and this is Markdown, and this is a second level heading, and this is a list. So Markdown is just a shorthand notation that a lot of developers understand for writing things. So something, if you want to emphasize something, you can put it in asterisks or underscores. No, underscores. It won't underline it. It'll italicize both of those things, and you can really emphasize with double, right? Or you can also go. You can triple emphasize things, as well as make it upper to shout, obviously. Like, it just basically understands Markdown, and it understands social media language as well. So that's helpful. And the other thing is you can this is typically understood as literal text in triple backticks. So you can see that it's formatted like code in a box. So, Markdown is the language that it will communicate to you with. So when you see its response, it looks like this to you, but it looks like this to ChatGPT. So if you want it to output triple quotes, it's going to accidentally format it funny. So there's that. So, but did that
sounds good? And
yeah.
We've taken a lot of your time, so I'm going to give one last question.
Yeah.
And it's from Jennifer, class of 95. She said,
Yeah.
I've had some experience with AI introducing errors to my data set when I'm just asking for help with the narrative. Similar question, maybe you kind of talk about both from Denise, class of 87. Can you find tips for structuring prompts to reduce the hallucinogenic nature of AI responses? I know you talked a little bit about mistakes throughout, but maybe a last word on hallucinogenic nature of AI responses and errors.
Yeah. So the best advice that I can give you with respect to that is that you want to ground your model. Oh, by the way, real quickly, when ChatGPT came out with GPT-5, you lost the ability to kind of it had a router. So sometimes you might want to say think fast or think slow. Otherwise, it'll take a long time. But if you want to avoid hallucinations, the main advice that I have for you, if you're doing the prompt engineering yourself, you would use something called RAG. And there are tools to help you support that through the IDE. But if you're using ChatGPT, if you hit here on this plus sign, you can enable certain things. So I'm here in a temporary one. Let me get out of the temporary one. If I hit here on this plus sign, you can add photos and files, or you can tell it to, for instance, use a web search, right? So here we go, a web search. So from within something like ChatGPT or Claude, you can enable this web search. And when you do that, the problem is that these large language models, the way that they're trained is imagine that you're a student and you're getting a multiple choice exam and you don't know the answer to the question. One thing that you could do is you could say, I don't know. But the other thing that you could do is guess. But if you say, I don't know, you pretty much always get it wrong. But if you guess, you'll get it right a certain percentage of the time. And so, like, recently, people have really found out that a big part of the problem is we just keep asking the model to guess. And so it's going to hallucinate. Over time, models might just get better at not hallucinating. But for now, the best thing that you can do is try to get it to ground its answer with a reference. So you might just say, tell me when Miami University was founded. Try to give me a reference for the answer. And then you say check. and it will be able to, because I've enabled a tool called web search, it's going to come back, and just like I showed you behind the scenes, we're not seeing it. It might come back and say you need to do a web search. Can you please clarify which university you meant? If you meant Miami University, it was founded in February 1809, and you can see here it's got a link that you can go back and confirm. So in order to prevent the hallucination, trying to encourage it to use retrieval augmented generation of some sort, or a tool like web search, and it's called grounding its answer in that, is the best advice I have. And then you can go back and check its answers. There are tools that live on top of ChatGPT, like Perplexity. You can switch between ChatGPT and Claude. That really, they're all about making sure that it grounds its answers in retrieved facts. But that's the go-to answer to mitigate. It doesn't completely remove, but to reduce the amount of hallucinations that it does. Ask it to check its own work. Please double check your references. And I meant Miami University. But my text-to-speech didn't get the word Miami before. So you can actually get it to go back and confirm and explain itself. And that's another good thing to do to try to get it to reduce hallucinations. But sometimes it can get stuck in a loop, and people will maliciously put bad information on the web, which will cause it to come back with the wrong information and then keep going back and confirming itself with the same wrong information. Mm-hmm. So at the end of the day, there's no better advice than you just have to double check what it says. It's not a primary source. It's like Wikipedia. That's also not supposed to be a primary source. Now, the question about it ruining her data, I didn't understand that question. So I would assume that means she's giving it her data and asking for the data back, or maybe she's using Canvas or something, and she's asking for a change in one place, but it's making a change in a completely other place. Or perhaps she's using a tool like Copilot in agent mode, which can go out and do a bunch of things. And in those cases, I mean, that's the only way that I could imagine that it would ruin her data when she asked for a narrative. It could be the fact that the narrative she gets isn't actually based on her data, in which case I would ask her to tell it to include a justification or a reasoning. So there's a technique for prompting called chain of thought, or react, reason, and act, where you say don't just answer the question. First, explain the process that you use to get at the answer, then follow the process and explain step by step what you did, then finally show me the answer and confirm your reasoning, right? We use this less often because it's baked in to the reasoning modes like GPT-5. When they say reasoning, what they've actually done is they fine-tuned the model to make sure that it's better at going through those processes, and then they kind of bake that chain of thought into it. But if you want to see it and reinforce it, you can actually just ask it to explain itself as it goes. That's maybe a good way to make sure that the thing that it answered is actually grounded in the data. But I wouldn't let the model directly change my data without me looking at it. When you use Copilot and it wants to make a change, usually you've got a check mark where you can say keep or reject. That's you being the human in the loop. You got to be there. We're not in the full auto and trust it for something important phase of AI yet.
Yes. Okay. Yes. All right. That's a good way to finish. I think everyone wants it to be perfect and forgets that part of the scenario we're in right now. Yeah. But anyway, thank you so much, John, for sharing your time. Again, I know it's an extremely busy time of the year, and we really appreciate you sharing this. And the module you did for alumni, as a reminder, that's available Miami Online. The link is below your video on our webinar site if you're interested in doing the full AI Microlearning Series from Miami Online. That is there. And other than that, any last words before we sign off, John?
Well, I hope that this was useful. It's always hard when you talk to know where to target things. Like if you want to know how to drive the car and I just told you how the brakes work, that's probably not so useful.
Yeah.
You just need to know where the pedal is. But I hope that this was valuable.
Yeah, no, it's great. Great combination. If you watch this and you wanted to know a little bit more about basic tools, you can go back to Glenn Platt's, or a little bit more about basic AI, or the how we use AI. You can go back to those past ones as well. I think this was great in figuring out how to engineer our prompts a little better. So we really appreciate the time, John. And to all of you out there watching, thanks for joining us. Love and honor. We will see you next time, which our final AI talk in this series is on October 21st with Mindy Olenek, and it is writing, agency, and AI. So we hope to see you then or at other webinars. And John, one last time, thank you so much for your time. We will see you around campus.
Thank you.
Love and honor.
Bye.